Hello, hello, hello. Is this, let me just make sure this is actually working. I'm having some weird issues with OBS. Welcome one, welcome all. I'm not sure if the chat is going through, but maybe that's okay. Anyway, so here we are again. Today is the 5th day that I've been doing the stream. It's been going pretty well. I'm very happy with its progress so far. Without any further ado, we'll go ahead and get started. But I guess I should give a really brief intro. So to anyone that's watching for the first time, what this stream is intended to do is just to be able to provide like a way for people to be held accountable for their own LeetCode journey, whether it be that you're trying to look for a new job or you're trying to just sharpen your skills as a software engineer. I definitely believe that LeetCode is an important way to sort of iron that out. So at the very least, I just want to be a accountability buddy. And if you want to stay tuned and maybe you'll learn a thing or two, I'm always open to hear what you all have to say about the stream. So let me know if you want me to work on any specific question. But when I started this 5 days ago, today being the 5th day, I started at question 0, and my intent is to go through every single easy question, then every easy medium question, then every hard question. So we will be in this for the long haul, but hopefully, if you're all following along, we'll all get better together. And for anyone that is watching for the first time, I should make a quick, just a quick plug here. I have been uploading all of these videos to YouTube. And what that means is I've provided a way for people to, like, if you look at this video here, it says LeetCode Accountability Stream number 1, start here. And what you can do is you can start at the first stream, go all the way to, subsequent streams. And what I even started doing now is if you click on one of these videos, I have all the links of all the questions I work on. So you can click on the video and start working on the questions and then watch the video after, or, work on the questions alongside watching the video. And hopefully that'll sort of motivate you and maybe teach you a couple things you may have not already known. So I was going to revisit a question from yesterday, but I believe I already added this to my list of questions. Let me see actually if I open my list, how does this work here? Create target array. Yeah, what I want to do is I want to add this one to my list. What I plan on doing is like once a week on Saturdays, I probably will go ahead and do questions from this list. That way we can continue moving through the questions and then we'll just do like a weekly roundup at the end of the week. All right, so let's get to this first one right here. So balanced strings are those that have an equal quantity of L and R characters. Given a balanced string S, split it into some number of substrings such that each substring is balanced. Return the maximum number of balanced strings you can obtain. Okay, so let's see. RL, 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 RL. Okay, so I think just from like experience, I can already see how to do this, I think, but that theory will be proven shortly. So when we're parsing strings, a very common data structure to use is a stack. And I'll try to like draw an example here of why that might be helpful. So we see that a balanced string is one that has R and L that is balanced. So for every single R that we put onto our stack, we can push onto the stack. And then for every single L that we have, we can pop off our stack. And essentially, anytime that stack is empty, we can go ahead and count that as being a complete one. That's like one way of doing it. And I also just even thought of another way that might be an improvement, but I think we should do both ways so we can get an idea. One of the reasons I know this method is because I've also, like, if you've done balanced parentheses, then you might realize the pattern right away. But I'll go ahead and get started here. So I'll create a new array. I'll call it balanced. I'll set it equal to an empty array. And what we can do here is we can say for const C of S, we will either do a push or a pop operation, right? Push, pop. It'll only ever be, well, I guess I can always check it. So let's do this. If C is equal to R, then we can do balanced dot push C, else balanced dot pop, right? If balanced dot length equals 0, and let's say number of balanced strings, I'll create a new array and call it balanced strings. I'll set this equal to 0. And then maybe here we can say balanced strings plus plus. and return, we'll go ahead and return balanced strings down here. Balanced strings. So I want to go through this before I even, so what I'm going to do here is I'm going to run the code before I even take advantage of the run code button on LeetCode, because this will also get me in the habit of testing my own code and not having to rely on LeetCode. So let's think about this, right? We have an empty stack to begin with. We're at the first one. We see, okay, that's an R, so we're going to push R. Now we see an L, so we pop, and now this is empty, so we can say balance strings is equal to 1. Now we go to the next R. We push an R. Now we're at the next R. We push another R. We get to an L. We pop. We get to an L. We pop. We're again at lane 0, so we increase balance by 1. Now it's 2. We're at another R. We push R. Then we see an L. We pop. Again, it's empty. That becomes 3. We see an R. We see an L. We see an R, so we push. We see an L, so we pop. That's empty. And now we push. So we have 4, which gets us this balance string over here. Let me now copy this next one, which should be 2, and let's see what that does for us. See if my theory still works here. All right, so we start at 0. We have an R, so we push an R. We have an L, so we pop. It's empty, we push. We have an R, so we push an R. We have another R, so we push an R. We have another R, so we push an R. Now we have an L, so we pop. We have an L, we pop. We have an R, so we push. We have an L, we pop. We have an L, we pop. It's empty, we increase to 2. So I think this is going to work, right? I feel like it's going to work based on these 2 test cases we have. So let me go ahead and run this. It should at least give us what we just tested, 4, 4. Let's run it with all the example test cases. 4, 2, 4, 4, 2, 1. All right, so here's one bug over here. Let's see what we need to work on here. L, 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 R, R. Oh, okay, so let's see. Is the first one, like S can be split into L, L, L and R, R, R. It just has an equal amount. Let's see, equal quantity of L and R characters given a balanced string split to some substrings. So it doesn't really matter. Let's see. L count is 1, 2, 3, 4. R count is, so how about when both of these are 0? If I see an L, I can increase it. If at any point both of those are 0, R and then an L, that's 1. To the same, plus, 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 minus, minus. Oh, interesting. We were close with that stack solution. So perhaps it's not going to be, yeah, because we can't pop off an empty string. Maybe we can make it generic enough that like we don't really care what letter. So which one is going to be the one that we pop? Which is going to be the one that we push? Should always just be, maybe it should just be whichever one is, okay. So let's do const, let's say like anchor car is S at 0. If C is equal to anchor car, we'll push C, else we'll just pop. What does this do? 4, 2, 1, 4, 2, 1. If we run this, R, L, L, L. Okay, let's see. Let's see what's up with this one. So we have this string over here. What I'm going to do is something very similar to what I just did. So let's say R is our anchor. So we push R, and then we pop. Do we pop again? I don't really want to pop again. Maybe instead of keeping, I'll put 4 expected 3. If I do 1, 0, -1, R0, -1, -2, -3. Maybe there's something else that I'm missing here. Let me count the frequency of characters here. I have 4 R's and I have 5 L's. We can only make, right? Oh no, I have 1, 2, 3, 4, 5, 5 R's, and then 1, 2, 3, 4, 5 L's. Expected 3. Note that S cannot be spent to R, L, R, R because second and fifth substrings are not balanced. Equal quantity of L and R characters. Given a balanced string S, number of substrings such that each substring is balanced. So I saw that like the stack wasn't working for us. I almost thought it would because in my head I would say it's very similar to like the balanced parentheses problem. So for this one, let me see submissions in here. Else balance pop. I also don't really want to, wouldn't want to sort it either. R, L, 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 R, 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 L, R. Split a string in balanced strings. Those that have an equal quantity of L and R characters. Given a balanced string S, split it into some number of substrings such that each substring is balanced. Return the maximum number of balanced strings you can obtain. I'm thinking of the maximum number. Ooh, we're close with that stack solution. Sweet, I want to parse the string. Equal quantity of L and R characters. That has equal quantity. That has equal quantity. That has equal quantity. Okay. R, L, L, L. Output expected here is 3. We can do an LR. We can do an LR. Oh, because we can do an RL, right? We can do R, then L, and then we can do LLL, RRR, pop, and then LR. What if I were to assign 1 and -1, 1 plus -1? Okay. Negative. Like if we do 1 plus 1 plus -1 is 0, and then we do -1, -2, -3, -2, -1, 0, -1, 1, 0. We can also maybe just use like a counter. Perhaps that can sort of, yeah, what if we did that? It's like forget about this. Let's forget about this because it's just test. Let's forget about having balanced. We can have balanced strings. I can just say let count equals 0. And let's just give like an arbitrary, let's see, if C is equal to R, what if we say count plus or equals 1, else count minus equal 1, if count is equal to 0, balance strings plus plus. So let me copy this one. Let's come to our console here. I want to get all my test cases. Copy this one here. But let's like try this out, right? So 1 minus 1, that's 0. 1, 2, 1, 0. Okay, so 1, 0, that's 1. 1, 2, 3. 1, 2, 3. And then 2, 1, 2, 1, 0. 4, 1, 2, 3, 4. 1, 1, minus 1, 1, 2, 3, 1, 2, 3. So that's 3. 4, 2, 1, 3, 4, 2, 1, 3. Does this one work? Okay, so 11.55. So it's very interesting because here, I'm very curious why. Oh, because whereas the thing is, okay, so I think what happened here was like if I'm using a stack and I pop off an empty stack, I can't really do anything with that. But like the number will indicate that we've removed some amount of letters from this solution, right? So what was happening was in cases where I was doing like L, for example, I start off with an empty, and then I'm popping off nothing, so I'm never able to reflect that I'm, I guess, down or below 0 to then be able to come back to 0 with a count plus 1. So I'm pretty happy with this answer. It's linear time and constant space complexity. So I'm curious what the discussion has to say. Yeah, greedily split the string, and with the counting, when the counter is reset to 0, we get one balanced string. Okay, so something good to maybe like a good, I don't want to say pattern here, but maybe a good, I guess, way of thinking of this is like if if we're able to, if having a stack being empty means some terminating condition, or if we don't have to consider like a value below 0 or something that's less than like an empty stack, if that makes any sense at all, then maybe we should use a counter, just like we did in this case. So I'm going to move on from this one, feel pretty good about this one. I'm also going to take a note of this because I want to add it to the list of questions that we're covering. Cool, so count items that are matching a rule. Okay, so this one says you're given an array items where each items of I is type, color, and name. So given an array of items where each item's I, okay, so can we do something like for const item of items, const type, color, name equals item? What I'm doing here is I'm just like based on what we're getting in the description, I just wanted to set up a loop that does some destructuring for us. It makes it very clear what we're pulling off, and now we'll see if we can, compare this. We're also given a rule represented by two strings, rule key and rule value. The ith item is set to match the rule if one of the following is true. If the rule key is type and rule value equals the type. Oh, so I see. Okay. So we can say let matching items equals 0. Now we can really just use this to our advantage. So we can say if rule key is type. So we can say switch rule key. Instead of here, we can say type. Let me just set up all my cases. Color or name. So if actually no, if and rule value equals type, if type equals rule value, matching items plus plus, break. Should be able to just do this for all the subsequent ones here. Of course, we'll have to change the case here. If type, if color equals rule value, if name equals rule value, matching items plus plus, break. And we can return matching items here. See what this gives us. Seems like it'll work. Of course, wow, quadruple evil equals. That's something new. Output expected 1. Let's run some more test cases. 1, 2, 1, 2. Let's run this. Okay, 9.64. Very curious. I'm gonna pull up the solution whenever we get to it, 44.49. But let's think about this first. So if we think about time and space complexity, the time is linear because we're having to iterate over the entire items array, and the space complexity is constant as we're not creating any extra auxiliary storage to be able to complete this algorithm. Really what we're doing is, again, I set up some simple destructuring here using array destructuring on item, so we can easily identify the type, color, and name. And now we can really just say, we can just, yeah, pretty much just using exactly what they have. I can maybe condense this if I do just a simple if statement, like if type equals rule value. Oh, but we still need to check, yeah. If rule key equals type, yeah, it'll actually look pretty unwieldy. Let's see what discussions have to say. Easy and short, 100% memory. Yep, yeah, pretty much exactly what we did. So yeah, pretty happy with that question. It's a pretty easy question. Yeah, you'll notice that as we go through these questions, there's going to be some that are really easy. There's going to be some that are harder easies. Like I can for sure say that some of these that are apparently, my theory is that they're higher acceptance rates because they're harder, more people are doing research into them, and that's probably why their acceptance rates are higher. Not because they're easier, they're just more well known, so more people will probably attempt them. Okay, so sorting the sentence. A sentence is a list of words that are separated by a single space with no leading or trailing spaces. Each word consists of lowercase and uppercase English letters. The sentence can be shuffled by appending the one indexed word position to each word, then rearrange the words in the sentence. It's one index, so 0, okay. And the index is always going to come at the end. Is that what we're getting? Okay, given a shuffle sentence S containing no more than 9 words, reconstruct and return the original sentence. So let's think about this. If I split this into spaces, like this is a sentence, I'm going to need 4 slots and I have 3 spaces. So what I should do, apologies, I've been sneezing a lot today. So I think at least a brute force way that I can do it is I can calculate the amount of spaces I have. I'll create I'll create a new array that has the amount of spaces plus 1 to account for 4 different words. And then I'll loop through each one of these, grab my index, and then put it in that spot. So a couple of things that are going to be happening. So let's take this one by one. So let's first create the, I guess, sorted array, and this is going to be equal to, let's see, s dot. Can we do, is split only on an array? I don't know why I'm forgetting this right now. Okay, string split, yeah. Let's do s dot split on space dot length plus 1. So again, we need a like if I need 4 indices, I can get the amount of spaces, which is 3, and I can add 1 to account for all 4 of my words. Okay. Now we can say for const c, or for const word, and I'm also going to want to go through, I'm also going to want to probably keep this split one. So let's say const split s. For const split equals s dot split. This variable is just going to hold my split. Now here I can say split.length plus 1. Now for const word of split, what is it that we want to do? We want to get the index. The index is going to be the last thing in this string, and we want that as a number. A couple things we need to do though, right? First thing we can do is we can say parse int. We can say parse int of word at word.length minus 1. I'm also going to pass in the radx here. But we need to do minus 1 because this is one indexed. So if we're starting here at like sentence 4, we're going through split. So this will just be like the first thing. The index is going to be word at word.length minus 1, 4. We're going to parse int this whole thing to get the digit 4, and then we'll subtract 1 to get 3 to account for the one index word position that we're given. And the word itself, let's see, we really just want to go, can we get everything but, no, we can always go from 0 to length minus 1. So we can say, let's say sliced word equals word dot slice from 0 to word dot length minus 1. And if I remember correctly, string slice, yeah, that should give us a portion of that. So let me just remove some of these, sort. Okay. All right, so we have our split. I'm creating split here because I'm going to use it in multiple places, so just to make it easier to read. Create sorted split dot length plus 1. For each word of our split array, we're going to get the index, which is the parse int of word dot length minus 1, passing in the radix minus 1. And the sliced word is just going to be word dot slice of 0 to word dot length minus 1. So we'll get everything up to the last thing, which should just give a sentence. And now we can say sorted at index equals sliced word. And at the end, we should be able to have return sorted.join by space. And let's see what this gives us. So this is a sentence, and now we have that extra leading space at the end. Interesting. Why would we have that? Am I adding an extra space where I don't need it? Okay, no, that definitely didn't help. So this is a sentence. And why are we doing that exactly? Slice. Oh, actually, no, that should be fine. This is a sentence. Do I need to go? Does it actually get index n, the index of the first character to exclude from the returned string? Index of the first character to exclude, but it worked for every other one because const word of split, split is s dot split. So if we do this, we should split on the space. So we get this, right? And sorted, near array split dot length plus 1 for const word of split. If we're here in myself 2, index is parse int of word at word dot length minus 1, 10 minus 1, which is 1. And now we just have from 0, just to make sure here, string dot slice input. So starting, okay, we start from 0. We go to the length minus 1. That's the first one we want to exclude. So for this one, why would that happen? Can we get? Let's see what we're getting for each word here. Yeah, is sentence 4, this one, A3. Okay, that seems fine. That's pretty much what I expected for that. Let's get our index. Right, this is a sentence. 0, 1, 2, 3. Okay, that's fine. And sliced word. Word dot slice of 0 to word dot length minus 1. I really don't want to just like, this sentence is a, I could trim, but that just seems odd. Sorted new array dot split dot length plus 1. I mean, I suppose we could do this, but it's not very elegant. It'd be a strange thing to have to do. Really not sure why that'd be happening. Me, myself, and I. Let's see if this runs. 66.47. Run it again. 68.3. Run it again. 31.0. Let's check the solutions out. String split and join. So the word here, please explain. Answer word car is 1 base index. Deducted by 1. Yep. So let's see. S.split answer is new string of words dot length. Is it because we're adding? Wait up. Should I not even be concerned with that one? Oh wait. Really? Okay. So that saved a lot of time, just not having to do that trim. Yeah, I mean it increased the percentage by almost 20%. So we're doing a split here, which is most likely going to be n time plus another n. Now this word slice, sorted dot join, this one, okay. Yeah, I would like to see like word dot slice, JavaScript string slice, time complexity, string slicing. Yes, here it is. Optimize string slice into O1. Wow. Slice string class describes strings that are substrings of another sequential string. Really? Adventures in the land of substrings and regex. So V8 actually has constant time complexity for string slicing. So it would be O of n if that's true, because the split most likely is linear plus another linear operation. That's 2n. Drop the constant 2, just becomes n. But then you might imagine for each word we're doing some slicing, but if that's constant, then that's fine. So because of that, it seems like time complexity will be linear, and the space complexity would also be linear since we're creating this sorted array at the end. That's going to be the same size as the split length. So pretty cool stuff. So yeah, like I mentioned earlier, this is where I have to stop today. I have to make a slightly shorter stream. I actually have a lot of cooking to take care of, so I'm going to go ahead and do that. But it was a lot of fun to be able to do this again today with everyone watching. I had a fantastic time doing it. I really have been enjoying this. Just again, for anyone that's catching this right at the end, so I will be uploading all these to my YouTube channel. And again, my YouTube channel is so that you can come here, you can watch all the streams. I even put, start here for this one, so you know to start here. All the different streams now have links to all the questions that we've worked on. So you can work on the questions yourself and then watch the video afterwards, or you can watch the video at the same time. But again, it's really to be, held accountable for what it is that you're doing and hopefully just make your life a lot easier. So I know that LeetCode grinding is not extremely fun, but hopefully we can all get better and achieve our goals. So thanks everyone again for watching. I will be here again tomorrow for the 6th installment of this LeetCode accountability stream. Hope to see you all there. You guys all have a great evening or morning, depending on where you're watching from. Take it easy. Later.